Good morning, my name is Abelardo Sánchez, and I'm going to present my work titled as Synthesis of Arylalkynyl biphenyl derivatives for application in optical waveguide. Biphenyl group is widely used in different science fields. Some examples of these are medicinal chemistry, present in a big number of drugs. They are used as liquid crystals for its electric properties, or by the notorious application in electronics working as semiconductors, OLEDs, or solar cells. In this work, we have focused on the use of the biphenyl group as optical waveguide to be applied in miniaturized integrated photonics that could replace, in the future, the typical electronic devices. As can be seen in the slide, this is the structure of arylalkynyl biphenyl derivatives chosen for the study. On the one hand, ethinyl acts like a bridge in the molecular structure, and its report to enhance intermolecular PP interactions. On the other hand, biphenyl confers great conjugation, facilitates the crystal formation, and provides chirality to the molecule. Finally, trifluoromethyl and methoxy groups were chosen to compare the different packing and light transmission properties they would provide. Synthesis was performed by a sonogacero cross-coupling reaction to 4,4-diiodo-biphenyl. Firstly, the reaction was carried out under microwave irradiation, using less time and solvent volume, what makes it an environmentally benign synthesis. The compounds were successfully obtained, but due to the low yields, the synthesis was carried out under classical calefaction, improving the yield of the products as a result. Supramolecular aggregates were formed by a slow diffusion technique, which consists of dissolving a small quantity of the compound with a rich solvent and then introducing the vessel inside a bigger one filled with a poor or unsolvable solvent. After some days, crystals were formed and subsequently studied by SEM or XRD. SEM provided information of the morphology of the aggregates, and XRD provided the structural information of the crystal, as molecule packing, intermolecular interactions, and distances. Then, confocal studies were performed, showing that the obtained aggregates had bidimensional waveguide behavior, which are very promising results for their implementation. However, optical loss studies are being carried out to quantify how good light guidance is in the crystals. As conclusions to this work, it could be said that a series of arylalkynyl biphenyl derivatives was successfully synthesized by different procedures. The supramolecular aggregates were obtained with a good morphology by a slow diffusion technique. Characterization studies were performed to the crystal, which exhibited bidimensional optical waveguide behavior. Finally, I would like to thank my group, my lab partners, my directors, Pilar Prieto and Ivan Torres, University of Castilla-La Mancha for the funding, and all of you for your kind attention.